This is the video key for Quiz 1 for MAT181 for Fall 2015. First, let's take a look at this first problem. This quiz is on limits, and they're asking you what's the limit as x goes to 2 of this function. The first thing we want to try is substituting. So you put a 2 in for x, get 2 squared, which is 4 minus 4, over 2. So 4 minus 4 is 0 over 2. So we know we're going to get 0, but we have to show that actual substitution. So when we substitute, we lose the limit, this notation, because we're using it to substitute in. You get 2 squared minus 4 over 2, which is 0 over 2, which is 0. Remember, 0 over 2 is equal to 0. It's not undefined. And that's our answer for that one. For the next guy, when we go to substitute our 2 in, we get 2 minus 2, which is 0 in the denominator, and that's undefined. So we can't substitute. The next thing to try is factoring, and yes, that numerator factors. So let's go ahead and factor that. Don't forget your notation, the limit as x goes to 2, because we haven't taken the limit yet. The numerator is x plus 2. Sorry, that is not writing very well. X plus 2, x minus 2, all over x minus 2. Divide out those common factors. It goes in each of those one time. So we get, and we haven't taken the limit yet, so we keep that limit notation until we actually take the limit, x plus 2. Now, we're going to try to take the limit. We can substitute the 2 in. Nothing's undefined, so yes, we can substitute. So we get 2 plus 2, which is 4. Let's look at part C. For part C, when we put in a negative 3, because we want to try to substitute first, it's 2 times negative 3 is negative 6, plus 1 is negative 5. Square root of negative 5 is an imaginary number, so it's undefined in the real number system. And so for this guy, we're going to get the limit doesn't exist, but we have to show that substitution. So let's do, we're going to actually substitute, and we get negative 3 minus 4 over the square root of 2 times negative 3 plus 1, which gives us negative 7 over the square root of negative 5. And that is undefined. So therefore, our answer is limit does not exist, and you have to say why, because or since the square root of a negative number is undefined. So you have to take that last step and actually say why the limit doesn't exist. Even if you have here substituted in and got undefined here, you need to talk about it with respect to the limit and say the limit does not exist because of that square root being undefined with a negative number inside. Now let's take a look at number 2. You're given the graph of the function. Here's the piecewise function, 2 pieces. When x is less than or equal to 1, you're getting this left portion of the graph. When it's greater than 1, you're getting the right portion of the graph. And they're asking us to find the limit for each area. Now, you could, the first thing you want to do is substitute the number in that you're taking the limit with respect to. But remember, just because a function value exists at any given x value doesn't mean the limit is the same thing. So you have to be careful there. Don't just substitute in. For this one, you have 2 choices. You could numerically create a little table here and run numbers from the right, and then make a table here and run numbers from the left. Or you could just use the graph. So let's take a look at the graph. From the right, and remember, we're going to negative 2, not over here where the curve breaks at 1. As x values come from the right, the y values come around here from the right to this point, negative 2, 4. And from the left, as the x values come close to negative 2 from the left, the y values are approaching that same point, negative 2, 4. So the limit is 4. And we say that for part A, as x approaches negative 2 from the right, the limit is 4. by the graph, because that's what we're using. And then as it approaches from the left, so part B, the limit is 4 again by the graph. And then for the final one, because the left and right limits are equal to each other, the limit itself as x approaches -2 is 4, but you have to say why. So because or since the limit as x approaches -2 from the right of your function is equal to the limit as x approaches -2 from the left of your function is equal to 4. So since those limits are equal to each other and they're both equal to 4, the limit itself is equal to 4. So this one is done graphically because you're given the graph. Be very careful. You cannot just substitute values into here because that's giving you a function value which not necessarily will be the limit. So you have to be careful there. So that's it. The other quiz was a different version with some slight differences. If you cannot make that jump from this key to yours, just come in and see me and I'll be happy to help you. That's it. Hope you're having a great day.